In this video, we're going to go over illustrative mathematics, Algebra 1, Unit 2, linear equations, inequalities, and systems, in particular solutions to inequalities in one variable. Our learning goal for this video: let's find and interpret solutions to inequalities in one variable. So here's our number line, and here's our problem. Write some solutions to the inequality y is less than or equal to 9.2. Be prepared to explain what it means, what makes a value a solution to this inequality. And our second question: write one solution to the inequality 7 parentheses 3 minus x is greater than 14. Be prepared to explain your reasoning. Okay, for the first one, we want numbers less than or equal to 9.2. So for example, let's just rewrite it. Any number less, this means less than or equal to. So we have two scenarios to consider. So we know 9.2 is equal to 9.2, so 9.2 is a possible solution. Let's say 8 is a possible solution. 7, 5, 0, -1, -2. All these numbers are possible solutions. Okay, let's put those on the number line. Oops. Other way. So 9.2 is approximately here. Here's 9.2. So we said 8, 7, 5, 0, -1, and 2. And take note, all these are to the left of 9.2, meaning they're less than. We'll go back to that slide in a second. And the next one we want to think about is 7 parentheses 3 minus x is greater than 14. So we want to find, as we plug in, for example, let's say 1, that gives us 7 times 2 is greater than 14. That's saying 14 is greater than 14, which we know this is false. So if we picked any number bigger, let's say just to reiterate this, we'll say 7 parentheses 3 minus 2 is greater than 14. So that's going to be 7 times 1 is greater than 14, or 7 is greater than 14, which again, we also know that's false. We want to go the other direction. So any number less than 1. So for example, we could say 0, -1, 0.5, -2, -3. -0.5, and we could also say -4. So let's plot a few of these on our number line. So obviously +1, then we're going to put a -1, -1.5, -1, -2, -3, -4, -5. All these numbers are less than +1. So let's synthesize this activity. How do you know when a value that you chose is a solution? They were to the left on the graph. If we go back to our graph, we can see visually, here's +1. They're to the left of 1, or 9.2. Or they made the inequality true when we looked at plugging in the numbers. So they made a true inequality. What do you notice about all the points that are on the line? They were all to the left. Of the solution. On the number line, we can see that the solutions are values that are less than 1. All these values form the solution set to the inequality. Is there a way to write the solution set concisely without using a number line and without writing all values less than 1? That would be tedious. You'd be writing all day if you try to write all the numbers. So the simplest way to write that, you would just write x less than 1. Does the solution set have anything to do with the solution to the equation 7 parentheses 3 minus x equals 14? Yes, if we say x equals 1, both sides are equal, because remember, if we plug in 1, that's the same thing as 7 times 2, which is 14, gives me 14. So yes, it does have something to do with the solution to the equation 7 parentheses 3 minus x equals 14. And why does the solution to the inequality 7 parentheses 3 minus x greater than 14 involve numbers less than 1? If we use numbers larger than 1, we get a false inequality. Larger than 1, we get a false statement when we plug in. Off to an orchard. A teacher is choosing between two options for a class field trip to an orchard. At Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. Which orchard would be cheaper to visit if the class has 8 students? 12 students for part B and C, 30 students. So first, let's write our inequalities or equations. So this will be 9 parentheses n plus 3, where n equals number of students. For orchard B, the expression would be 10 parentheses n plus 1. Again, n is a number of students. So let's make a A and a B. So first we want to do for 8 students. So 9 parentheses 8 plus 3. 8 plus 3 is 11, so that gives me 99. So this is orchard A. Orchard B, we will do 10 parentheses 8 plus 1. 8 plus 1 is 9, so we get 90. So for 8 students, Orchard B is my cheaper route. I'm going to do the same thing by plugging in 12 to the same expression. So 12 plus 3 is 15. And 9 times 15 gives me $135. We'll check out Orchard B. So 10 parentheses 12 plus 3 gives me 12 plus 3 is 15, so $150. So still, for 12 students, Orchard B is my cheaper route. Now let's check out 30 students. 9 parentheses 30 plus 3. So that's 33. So 9 times 33 gives me $297. So now I can compare that to 30 plus 3 for the second equation. So 30 plus 3 is 33, and 10 times 33 is going to give me $330. So for 30 students, Orchard A is my cheaper route. To help her compare the cost of her two options, the teacher first writes the equation 9 parentheses n plus 3 equals 10 parentheses n plus 1. And then she writes the inequality 9 parentheses n plus 3 is less than 10 parentheses n plus 1. What does n represent in this situation? So the n, which we already discussed, is the number of students on the field trip. In this situation, what does the equation 9 parentheses n plus 3 equals 10 parentheses n plus 1 mean? So in this situation, it's when the orchard A and orchard B, the cost is equal. So we'll say the cost is equal at orchard A and orchard B. What does the solution to the equation, to the inequality 9 parentheses n plus 3 less than 10 parentheses n plus 1 tell us? Since we know this is my orchard, that 9 parentheses n plus 3 is orchard A and 10 parentheses n plus 1 is orchard B, that tells us when it's cheaper at orchard A. Orchard A. Graph the solutions of inequality on the number line. Be prepared to show or explain your reasoning. So, if we try to solve this, we would say, and we'll do some more of this in our next lesson, 10 parentheses n plus 1. So it'd be 9n plus 27 is less than 10n plus 10. We'll subtract 9n from both sides. We'll subtract 10 from both sides. So the 10s are taken care of, the 9n's taken care of. So we're left with 17 is less than n. So, or we can write it as n greater than 17. So we can just draw 17, 18, 19, 20, 16, I'm skipping them a few, 15, 14, 13, 12, 11. So we'll put an open circle above the 17. And we want to know when n is greater than 17, so we're going to draw the arrow to the right. If we put the n on the right side, the arrow, take note, the arrows face the same direction. So one thing I do want to point out, when we use greater than or less than, we're going to use an open circle. And that's what we put above the 17. Okay, 7, calculator die, 7.50, parentheses, 16, plus 50 over 4 parentheses 16. So for this situation, it's 320. So if we plug into the second equation, that'd be 18 parentheses 16 plus 33. And recall that's the hotel. So let's see what they offer at 16 hours. 18 parentheses 16 plus 33 gives me $321. So the student works fewer hours than the solution you found. If so, which job? That would be the hotel. We can see that by our solutions. At the restaurant, we're earning $320 at 16 hours. At the hotel, at 16 hours, we're earning 321 hours. the student works more hours in the solution you found. If so, which job? Let's just plug in 17. So we're going to do the same task. 7.50 parentheses 17 plus 50 over 4 parentheses 17 and see what that answer gives us. 17. So already have it plugged in my Desmos calculator. So that's going to give me 340. Now I'm going to do the same task with 18 hours. So 18 parentheses 17 plus 33. So that gives us $339. So for that one, the restaurant is better. Let's keep going. Here are two inequalities and two graphs that represent the solutions to the inequalities. So you have inequality 1, 750h plus 50 over 4h. Remember, this is the equation. If we remember from the last one, we already defined it. That was the restaurant situation. And this is the hotel situation. So remember, the general solution was 16.5. So we're going to scale it just like before. So 16.5, 17, 18, and then 19. So we have 16, 15, and 14. We have 16.5, 17, 18, oops, let's get 1, 18, 19. We have 16, 15, and 14. So you put the same scale on each number line, so the circle represents the number of hours that you found earlier. Match each inequality with a graph that works. So inequality 1 was when the hotel was better. So remember from the previous section, oops, the hotel was better when we had 17 hours. Or sorry, 16 hours. So that would be B. And recall in the next one, we want to know when the restaurant is better. So if we go back to our previous slide, the restaurant was better when we had 17 hours. So that would be inequality 2. So, or graph A. So graph B represents when the hotel is better. Or inequality 1 represents graph B, that's when the hotel is better. Inequality 2, which represents when the restaurant is better, is graph A. So we're going to quickly regenerate these slides. 16.5, 17, 18, then 19, then 16, 15, and 14. 16.5, 17, 18, 19, 16, 15, 14. So in this situation, we have a system of equations. So that's when we make equals. So what we're looking at here in this graph is when they're equals. So at 16.5 hours, what's happening here at 16.5 hours, the pay is equal at $330. Okay, solve the equation, check your solution. This is activity 4, equality and inequality. So we're given the equation negative 4x plus 3 all over 5 equals 4x minus 2. So we're consider the inequality negative 4 parentheses x plus 3 all over 5 is less than or equal to 4x minus 12. So I'm going to choose a couple of values that are less than 2. So we're just going to use 1 just to get the idea of what's going on here. Are they solutions to inequalities? So for part A, we're just going to type in 4 parentheses 1 plus 3 all this over 5. So I'm going to use a Desmos calculator, which is installed on my phone, to get my answer. Three, and we're going to divide that by 5. And that gives me negative 3.2. So now we're going to plug in one to the second right side. The 4 parentheses 1 minus 12. 4 times 1 is 4, minus 12 is going to give me negative 8. So no, negative 3.2 is not less than negative 8. So no, the values less than 2 are not solutions. So let's do the same thing for values greater than 2 to see if they're solutions. So let's say negative 4 parentheses, let's say 3. Plus, and I forgot parentheses all the way around on this one, 3 all over 5 is less than or equal to 4 parentheses 3 minus 12. So on the left side, I get 4.8 when I plug in 3. And on the right side, 4 times 3 is 12, and 12 minus 12 is 0. So this one does work because 0 is greater than negative 4.8. So this one is true. And let's see what happens when we actually plug in 3. Let's erase because we're running out of room on this slide. So if we plug in 2, 2 plus 3 is, we're just going to use the Desmos app calculator. That's going to give me negative 4 once we plug it in. And 4 times 2 is 4 minus 12 is negative 4. So this time we have negative 4 is less than or equal to. This means less than or equal to. So that means the answer has to be less than or equal to. So they are, negative 4 does equal negative 4. So yes, they're still solutions. So we're going to graph the equation, the solution on the number line. So when we have less than or equal to or greater than or equal to, we're going to use a closed circle. So we're going to put a closed circle above negative 4, and we want all the values greater than 2. Sorry, we want to choose 2, so we want to put a closed circle above positive 2. We want all the values greater than 2. So we're going to draw an arrow to the right. What are some values on the number line that are not solutions? So we knew this was the correct graph. 2 with a closed circle with arrows to the right. So if we wanted to choose some values that are not solutions, we could say 1, 0, negative 10, negative 5. All these guys are not solutions. So if they're not 2 and greater, they're not solutions. Okay, activity 5, more or less. Consider the inequality negative 1/2 x plus 6 is less than 4x minus 3. Let's look at another way to find a solution. So we're going to use graphing technology to find the graph y equals negative 1/2 x plus 6 and y equals 4x minus 3 on the same coordinate plane. So I'm going to escape out the PowerPoint and bring up Desmos. Let's just shrink it down. So we'll say y, we'll just say f of x. So it'll make my job easier when I do a future question. So f of x equals negative 1 divide 2 x plus 6. And then the next one we'll call g of x. G of x equals 4x minus 3. This is function notation, by the way. So now we can answer the following questions. Find the values of negative 1/2 x plus 6 and 4x minus 3 when x is 1. So since I use function notation, all I have to do is say f parentheses 1, and that gives me the correct answer of 5.5 for the first equation. I'm going to do the same thing for the g equation. G of 1, and we get the correct solution of 1, we plug it in. What values of x makes negative 1/2 x plus 6 and 4x minus 3 equal? So we use our graphing technology. We want the intersection point, so we just click and we get a value of x equals 2. That's where the two lines meet. So that's x equals 2. For what value is negative 1/2 x plus 6 less than 4x minus 3? So we do know our values are equal to 2. So after 2, it's less than 3. So for any value less than 2, or sorry, greater than 2. I said that backwards. X greater than 2. So when x is greater than 2, let's reiterate that. When x is greater than 2, I can just click and add a point. Negative 1/2 x plus 6 is less than 4x minus 3. We can see that because the y values are smaller here, whereas the y values are getting larger over here on the line 4x minus 3. D, what values of x is negative 1/2 x plus 6 greater than 4x minus 3? We're going to use the same logic. So we want negative 1/2. So we can see less than 2, our y values are getting large. For example, at 0, it's 6. And it rises from there. Whereas if we add a point on this line, the values are getting smaller. So this one will be x less than 2. What is a solution to the inequality negative 1/2 x plus 6 is less than 4x minus 3? And that's when negative 1/2, so we already answered that in part C. That's just when x is less than 2. Let's move on. We already did our activity in Desmos. Previously we saw we could solve an inequality like this by first solving a related equation. Negative 1/2 x plus 6 equals 4x minus 3. Is the method of graphing similar to the process in any way? So Just reiterating what we saw. So we can just find the value that makes the two expressions equal. That makes expressions equal. How is the graphing method different? So the graphing method is different. Instead of comparing the values of the expressions by calculation, we can graph the expressions y equals the left expression, y equals the right expression, or f of x, g of x like I did, and see where the graphs intersect. So we're looking for an intersection on the graph. And previously defined solution to negative 1/2 x plus 6 is less than 4x minus 3. We would test x values are greater than and less than the solution to negative 1/2 x plus 6 equals 4x minus 3 and see which one would make the inequality true. How is the graphing method similar? How is it different? So we can say similar and different. So they're similar in that you're comparing two expressions. They're different in that the graphs allow us to see visually which graph has a greater y value on each side of the equation. So this is more, the difference is they're more, the graphing is more visual. And how to solve the equation 4x minus 3 equals 12x plus 3. Help with solving the inequality 4x minus 3 is greater than or equal to x plus 2. So if we know, for example, if we know the solution to the equation, it helps us. It helps solve the inequality. In this video, our learning targets were I can graph the solution to an inequality in one variable. I can solve one variable inequalities and interpret the solution in terms of the situation. I understand that such a solution to an inequality is a range of values, such as x greater than 7, that make the inequality true. So our culminating activity to test your understanding. We have which graph correctly shows a solution to inequality. We have 7x minus 3 over 9 is greater than or equal to 8 minus 2x. I'm going to show or explain your reasoning. So keep in mind, when we have greater than or less than, we want to open circle. When we have greater than or equal to or less than or equal to, we should have a closed circle. So use that as a hint to help you solve your cooldown activity. So hopefully this helps you have a brief understanding on how to find solutions to inequalities in one variable. I'll see you in the next video when we talk about writing and solving inequalities in one variable.